So this video covers the stoichiometry preparation problems. So in this question, it's asking about the mole ratio. Mole ratios are a concept we use throughout stoichiometry. And if you look at this balanced equation up here, you'll notice that there's either a coefficient, a number in front of the compound, or there's not. If there's not a number in front of the compound, then that's saying there's just one of them. Now, if there's just one of these and they react together, they can make two of these. So one H2 plus one Cl2 yields two HCl. That can be molecules. So one H2 molecule plus one Cl2 molecule yields two HCl molecules. But we don't often deal in reactions at the molecule level. Normally, we're looking at a whole mole of stuff. So this would be 1 mole H2 plus 1 mole Cl2 yields 2 moles HCl. And that works just fine. You can say that this number in front tells you the number of moles of this compound made in the reaction. Now, this is not saying that every time you do the reaction, you have to have 1 mole of H2. That's where stoichiometry comes into play, and that's what we'll be using through the rest of the unit. But in its simplest terms, one of these and one of these makes two of these. So the mole ratio is 1 mole H2 to 1 mole Cl2 to 2 moles HCl in this equation. So if we apply that to this equation, 2K plus Cl2 yields 2KCl. We know that two of these and one of these makes two of these. But what if we don't have 2 whole moles of potassium? What if we only have 1 mole of potassium? Well, if 1 mole of potassium reacts, that's half of 2. So you would make half of this guy and half of this guy. So half of 2, that would be 1 mole of this. Half of 1 would be 0.5. And half of 2 would be 1 mole. So that would be our mole ratio. 1 mole of K, half a mole Cl2 makes 1 mole of KCl. So the number of moles of Cl2 that would react would be 0.5 moles.